Math class. Today we'll be focusing on proportional relationships. In our previous 2 weeks, we talked about constant and proportionalities from a table, from a graph, and from an equation. So in this lesson, we'll be combining all three of those all three of those concepts to talk about proportional relationships that exist. Okay, so proportional relationships represents a constant rate of change. Okay, so that when we find K and it gives us the same K each time, that's the constant, and constant meaning same, rate meaning at the same speed of change. Okay, two things will be true about a graph that is proportional. First, we said the graph will have a straight line. And remember, we said that word was linear. Okay. And then second, it will pass through the origin. And remember, the origin was at 0, 0. Okay. If a table is proportional, we have to check for equivalent ratios. And remember, equivalent ratios was when we divided y by x. And if they were the same or constant, then we said that that table was proportional. So we're looking at these examples all at one time, and we're going to create and see how we can combine tables, graph, and equations all together. Okay, so it says the number of miles a white-tailed deer travel is shown on the table below. Complete the missing information and answer the questions. So the number of miles is here and the number of hours. So this is y and this is x, because y depends on x. However many hours ago, that's how far they go. Okay, so it gives us two sets of data points, here and here, and that's all we kind of have to figure out what the constant of proportionality is. But remember, all we have to do is take those two and divide. Okay, so when you divide, because we said this is our y and this is our x. So when we divide 84 by 3, we put that into the calculator. We get 28. So what is that telling me? That's telling me that for 1 hour, the deer runs or travels 28 miles. Okay, so this is my K. This is when we found our unit right here, 28. Okay, so that means we're going to double check though. Okay, so we're going to do another one. This is 196 over 7. If I divide 196 divided by 7, I get 28 as well. So that lets me know that my constant of proportionality is 28. Okay, so if I know that this is 28, that means that each one of these data points should follow in the same pattern of a constant rate of 28 miles per every hour that is traveled. So how do I use that, right? If I know that K equals 28, so how am I going to use that to find my equation? So remember, the equation, constant proportionality equation, was y equals kx. Well, we just said that K is 28. So that is y equals 28x. Well, we could say this in a way that kind of makes more sense, right? So we could say y, being our miles, equals 28 times h. So h being the hours, because we already know that y is miles, x is hours. That can help us figure out the other data point we need for this table. So if I was to say, well, and how many miles do I travel if I go 2 hours? So that's 28 times 2. So all I have to do is multiply my constant of proportionality times 2. I get 56. If I multiply it times 4, excuse me, I get 112. If I multiply it times 5, remember I'm just multiplying K times 5, I get 140. 6, I get 168. 8, I get 224. And 9, I get 252. Okay, so this is my data point. Now I need to take these coordinates or data and create a graph based off of that. So if I was to create a coordinate point, sorry, that would be 128, 256, 384, and remember, this is my X, this is my Y, 4, 112, 5, 140, 6, 168, 7, 196, 8, 224, and 9, 252. Okay, so I come over here to my graph and I plot these points. I know that my X's represents my hours and Y represents my miles. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so the way that I'm going to number them are by factors of increments of 28 so that it'll fit on a graph. So 28, 56, 84, 12, 112, 140, 168, 196, 224, and 252. So from there, I take those points and I graph. So I know that this is just like this, all the way up. And if I was to draw a line connecting these points, I have a linear straight line, okay? And this lets me know that my graph is proportional. But we already knew that it was proportional based off of the table. But this shows that the graph is proportional. So a verbal description of this is that a white-tailed deer travels at a rate of 28 miles per hour. Okay? And so what let me know that this was proportional? Well, I had three things. I had a constant rate of 28 miles per hour. Then I had a straight line on my graph. And then it passed through the origin. Okay, so once again, these notes will be posted on Canvas, so you can also take these down if you would like, copy them or pause the video as you go. So let's take a look at a couple more examples of how to tie them all together. Okay, so this time they give me a verbal description and they ask me to create a graph in a table. Okay, so it says the student council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they donate $7. Okay, so here it's asking me to figure out how much, given this information of increments, will I get here. Well, here, these 5 represents the number of t-shirts. Okay, and then this is the total donated. Total money donated. So they told me that one t-shirt equals $7. So here's my unit rate right here, $7 for one t-shirt. So then if this is K being 7, then how do I create my equation? Well, Y equals 7X. So the amount of money I make depends on how many t-shirts I sell. Okay, so if you want to plug this in to our equation, so here it would be 5 times 7, because I sold 7 shirts. That means I made $35. 10 means that I made $70. 15 means that I made $105. 20 means that I made $140. 25, $175. 30 is $210. $210. 35 is $245. 40 is $280. And 45 is $315. And remember the way that I'm getting these numbers, right? Because my money, which is Y, right, is when I multiply 7, which was my constant, times each shirt that I made. So 5, right? And this is how I got 35. Okay. And then I take all of that and I plot it on my graph, right? So note if I said 5, 10, 15, 20, 25, 30, 35, 40, 45. Notice that I label my graphs, okay? And then this one will represent the money. So this is labeling. This down here is called numbering. So just in case you get that part confused. Okay, so this would be 35 all the way up. We kind of know without having to write them in that these coordinates will match. And remember, if you forgot how I did the coordinates, I took my X, which is here. This is my Y. And I said 5, 35. So 5, 35. The next point will be 70, 10, and so on and so forth, okay? So you just base that off of that, okay? And then I draw my straight line. So it's proportional because we have a straight line. It passes through the origin. And then my ratio of Y over X, or my K, is constant and equal to 7, okay? So now we're going to look at a couple of verbal descriptions and see if we can determine if these situations are proportional or not. If not, then if it is, then we're going to write an equation to represent it. If it isn't, then we can't write an equation. So let's look at number 3. A restaurant charges $10 for a medium pizza and $1 for each topping. Okay, so is there a constant rate for something? If I'm saying there's $10 for this and then $1 for each additional topping, that means depending on how many toppings you have, your number of what you pay for will be different per person. So in this case, this is non-proportional. And once again, I'm going to say that again, because a person can order different types of toppings or few or as many as they want. This isn't proportional. These two aren't proportional to each other. One person isn't going to get the same amount, okay? A restaurant has all you can eat buffet. They charge $8.75 per person. See that per person? That lets me know that my money will always equal $8.75 times however many people I have. Or I could say Y equals $8.75, which is $1.75 times X. So yes, this is proportional. A restaurant charges $1.50 for a fountain drink with free refills. Now, this one, like, well, Ms. Brown, is this one proportional? Yes, no, maybe so. Well, yeah, because the free refills, it doesn't matter. It's free. That doesn't change. But they're going to charge you this $1.50 each time. So, yes, it's proportional. Okay. It's Y equals $1.50 times X, where X is the number of drinks purchased, and Y is the total cost. Okay. The next one says a restaurant has a build your own salad. It charges $3.80 cent per person. So here you should pretty much get it. You see that per, okay? That lets you know that we should have a constant of proportionality because each drink or each salad, sorry, is the same amount no matter who buys it. So Y equals $3.80 times X, where X equals the number of pounds of salad and Y equals the total cost. And then the last one, a vehicle travels at a rate of 60 miles per hour, 65 miles per hour. So, of course, right? This is proportional. We got Y equals 65X. X equals the number of hours. Y equals total miles traveled. I hope this video helps you to connect the 2 or 3 topics together. Stay tuned for any other assignments that come up. Please make sure that you do your IXL. Please make sure that you do the video quizzes that's associated with all videos. And then if you have any questions, please reach out to me. If you have not, by this time, submitted your assignment stating that you have made up all your work, at this point, grades will be finalized by tomorrow. So if you have not emailed me knowing that you have went back and did an IXL, went back and completed an assignment, I am not going to go back and check for you. So please email me and let me know for sure that you have done that. If not, then I cannot help what grades you get when the report cards come out next week. I hope you have a great weekend and I look forward to talking with you soon.